All right, today we are looking at adding and subtracting numbers written in scientific notation. I thought I'd just go through a few examples in your IXL practice sections here. Okay, this first one we have adding. Okay, you can add numbers in scientific notation when both of the exponent parts are the same. Okay, so you see in this one we've got 4.7 times 10 to the third plus 3 times 10 to the third. They are both 10 to the thirds, so we can combine them, okay? 4.7 plus 3 is 7.7, and the 10 to the third is going to stay the same, okay? We are not adding those 3's. Your exponent stays the same when you add those. Here's a subtraction one. 8.11 times 10 to the 7th minus 4.3 times 10 to the 7th. Same exponents, so we can subtract these. 8.11 minus 4.3 is 3.81, I believe, times 10 to the 7th. There we go. And no calculator on these. Okay, again, we've got both of these are times 10 to the third, so we can subtract them. Okay, 9.8 and stuff minus 1.6 and stuff is going to be 8.1 and stuff times 10 to the third. Okay, another adding. 5 plus 2.7 is going to be 7.759 times 10 to the fourth, not the eighth. We're not combining the fourths. Leave the exponent the same. All right, hoping we'd see some different ones by now. Let's see, this is going to be 7.31 times 10 to the 6th, right there. Okay, again, 7.27 times 10 to the 8th. 12.59. Oh, okay, good. Here's one that's different. Both of these are times 10 to the 4th. When you add those, you get 12.59 times 10 to the 4th. We're supposed to write our answer in scientific notation, and remember, scientific notation can't be 10 or more. So when we say we have 12 times 10 to the 4th, we actually have to take that decimal and move it back to the left one place to be 1.259. And because we made our number smaller, we took our 12 and turned it into a 1.2. That means our exponent is going to get bumped up from 10 to the 4th to 10 to the 5th. Let's see, 6.26 times 10 to the 7th. That's another regular one. And here we go. Here's another different one. These exponents are not the same. Okay, and you may have noticed too, well, I can't take away 9 from 1.2 without going negative, but we're not working with negative scientific notation right now. Okay, there are two different ways that you can do this. You can either adjust the decimal point on the one on the right, okay, move it back one place, and then you would now have 0.9 times 10 to the 7th. Then you have 1.2 minus 0.9 is 0.3 times 10 to the 7th. But remember, scientific notation has to be at least 1. Okay, so 0.3 has to turn back into a 3, which is going to make the exponent go from 7 down to 6 because you moved it to the right. Your other option is, let's see, you could move this over 1, and you could do 12 minus 9, and that would be 10 to the 6th. Okay, 12 times 10 to the 6th. But then 12 minus 9 gives you 3, and there's your 3 times 10 to the 6th. Either way works. See if we can get another one of those. Yeah, here we go. 10 to the 6th and a 10 to the 9th. We are not ready to add those. Okay, well, obviously we're not going to put 15.92. That's not any of our choices. Okay, if we change, I think I'm actually going to change this first one. I need to get 10 to the 9th. I've got to move my decimal point 3 places. Right now it's at 8. So if I move it back to the left once, it's 0.8. Twice is 0.08. And 3 times is 0.008. Okay. If I take 0.008 plus 7.92, then I get, there's the 7.928. And you just got to be sure you have the right exponent there, which is 10 to the 9th. I left this one alone, and I changed my 10 to the 6th to a 10 to the 9th because I moved the decimal back 3 places. So where'd they go? Right there. All right, one more like that. Again, we got 10 to the 8th and 10 to the 9th. We cannot combine those unless the exponents are the same. So I'm going to move my 4.04. I'm going to move it back 1. So it's 0.404 times 10 to the 9th. Then I can add, and I've got 7.404 times 10 to the 9th. All right. Anyway, I hope that gets you going. Yeah.